Okay, so the first group of the arthropods that we're going to look at are the arachnids. And the way I'm going to look at these, is a, if it's possible on the organism, is to look at how many body segments they have and how many pairs of legs, walking legs they have. Okay, so with the arachnids, they have 2 body segments and 4 pairs of walking legs. So I think you can see that pretty easily in this diagram of a spider. Easy to see the legs on the tarantula, and then the tick. And I do want you to notice that the tick is much smaller when it hasn't had a blood meal, so you can see how much bigger it gets when it has a blood meal. If you have your animals outside and you notice a tick on your animal, you don't want to just pull it off because you don't want to leave the mouth parts. And some of these ticks do carry disease, so you want to put some alcohol down, or maybe put the end of a hot match or something on the abdomen of the tick, and that way it's going to cause it to let go, and you'll be able to pull it off without it leaving anything on the skin or of your pet, whoever you got outside. Okay, so 2 body parts, 4 pairs of walking legs. Spiders and ticks you probably recognize. You probably recognize scorpions. And then mites, dust mites. So this is an electron microgram of a dust mite, but they, are in lots of places, and if you look closely, they have the 2 body parts and the 4 pairs of walking legs. Okay, so this picture, I believe, comes from the McGraw-Hill book, and you can see in this picture that there's also a horseshoe crab. So the horseshoe crab is actually an arachnid. If you were to turn it over, you can see that it has the 2 body parts, but if you were to turn it over, you would be able to see the 4 pairs of walking legs also. So the crustaceans, the second group within the arthropods, and remember these are jointed appendage organisms, also have 2 body parts. So the head and thorax are together, that's the cephalothorax, and then the abdomen, okay? And they have 5 pairs of walking legs. And so you can see the first 4 here, and then the last pair, of course, is somewhat adapted for eating. So if you eat lobsters in this case, there's a lot of muscle in those claws because they use those claws to catch things, and so that's what a lot of people either like to eat, the claws or eat the muscle that's here in the abdomen. So this picture is nice because it highlights the 2 body parts, and then you can also see the pictures with the different pairs of legs. On this crab here, you can see that he has pretty specialized eyes that he can stick up, but when he doesn't have them up, they would just go right here in this little cavity on the front of his head. So lobsters, we've looked at pictures. Shrimp, we've looked at pictures. Crabs, we've looked at. We haven't looked at barnacles, so I'm going to show you a picture of a barnacle here in a second. But a couple of these are really interesting. They're very short videos. The carrier crab shows a crab that picks up other organisms and puts them on his shell as defense, which is interesting. And then the coconut crab is one that eats coconuts, so it's quite a large crab. And then here's the barnacle. So I did put a barnacle video too if you've never seen a barnacle. So this you might make you think of a clam or something because it has the shell on the outside, but if you were to open up that shell, you would see that it had the 2 body parts and the 5 pairs of legs. And these are helping it basically to bring in particles of food that are in the water. Millipedes and centipedes, there's different names, long scientific names for these groups. I'm going to put them together because they both have a long segmented body. Okay, these of course have an exoskeleton, which makes them different from the segmented worms like the earthworms, but you can see that the centipede has a flatter body and the millipede has a little bit of a rounder body. So where the term millipede comes from. Milli means millions, and pede and pode both refer to feet. Okay, and so someone looked at it and thought, that looks like he has 1,000,000 legs. Really, there's 2 pairs of legs per segment, but that's a lot of legs. Okay, and in this one you can see they're scavengers, so they eat, rotting leaf matter and stuff like that that's on the forest floor. You can see that somebody's holding these giant rainforest ones. They just feel tickly on you. They don't bite. They don't sting. They're just scavengers. Okay, so they have an important role in the ecosystem. If we look at the centipede, centi is for 10. And so it looks like it has less legs, 1 pair of legs per segment. But these organisms are very aggressive. They're carnivores, okay? So you can see here that this centipede has actually caught a mouse, which it is eating. And the centipedes do have stingers, and so if you find a centipede in your house, I would say pick it up with a piece of paper or something and take it outside. Don't pick it up with your hand because they can sting you. So you've got the 2 that you can kind of compare. Number of legs per segment and the shape of the body. One is flat and one is round. And so we get to the insects, and with insects there's 3 body parts. And so I like to show an ant because it's really easy to see on the ant that they have the 3 body parts, and then they have 3 pairs of legs. So this up here is not legs, those are antennae. And you can see on this bug here, you've got a head and a thorax and an abdomen, and the same thing with the grasshopper. So that's how you would, you have some kind of bug crawling around in your house. You can look at it and you can decide whether it's an arachnid or an insect or a crustacean or whatever. So you do have a picture in your book. I am not going to ask you to label it, but you can see here that they're pretty complicated. They have 2 kinds of eyes. Actually, a lot of these insects, they have simple eyes and also compound eyes. And then we said that the arthropods are the most successful animal group. Of the arthropods, the insects are the most successful. They have wings, which means that they can also take advantage of the air and not just be on the ground. So cicadas, we've seen a lot, at least for me in my yard, I've seen a lot of the cicadas come up. I think this is the 7th year. And so they've come up out of the ground and molted and left their exoskeletons. But butterflies and dragonflies are also examples of insects. And mosquitoes. So mosquitoes are kind of bad right now. You got to kind of be careful because mosquitoes can be vectors and carry different kinds of diseases. But on all of them, it's pretty easy to see the 3 body parts and the 3 pairs of legs. And I would just like you to be able to recognize that and then give me some examples. This picture is hopefully not too gross for you, but here you can see that the cicada is coming out of the exoskeleton, so he's going to grow a bigger exoskeleton as he grows that will encompass his whole body. And then I didn't put bed bugs on the list. I want you to see what they look like because that has been a problem from time to time where they end up getting in the bedding or the mattresses at a hotel or something that you've stayed at, and then they get into your stuff and then you may bring them home, and they're kind of difficult to get out. So it's something to kind of watch for, maybe read reviews of a hotel if you're going to go stay in a hotel to make sure that they don't have anything with bed bugs. And then I put this on just for fun because I came across this as I was researching something else. But just like we talked about how we have scientists at the University of North Carolina that are big fans of Lady Gaga, and then when they discovered a new fern, they incorporated her name into the scientific name. The person who discovered this fly, it's actually a horsefly from Australia, but it has this gold butt And so they called it the bootylicious fly, and they actually named it after Beyonce, so it has Beyonce's name in the species name of the scientific name of this organism, and this of course would be an insect. So our last group of invertebrates are the echinoderms. And the big step up here for the echinoderms is all the other organisms we talked about were protostomes. The first opening is the mouth in the embryo or in the early development. The echinoderms, the second opening is the mouth. And we will talk more about development when we get to the reproduction and development chapter. But echino refers to spiny and derm refers to skin. So you can see all these different examples. We've got a sea urchin, we got a sea star. This is a brittle star and a sand dollar. They all have the spines on the outside. Okay, now this is where we really see a step back. They're way at the top here because they're deuterostomes, but the step back is that these organisms as adults have radial symmetry. That's considered not as advanced, okay? When you look at the larva, it has bilateral symmetry, but when it becomes the adult, it has radial symmetry. So that's something that's a point to be made about these organisms. They do have a skeleton. It's an endoskeleton, and it's made of calcium. So that would be inside from where all of these spines are located on this organism. What's unique to the echinoderms, they're the only ones that have this water vascular system with tube feet. So you're looking at a sea star that's been opened up. Excuse me. The water vascular system starts up here in the middle, and then it has these tubes that run down each arm, and they have water in them, and they end in what we call tube feet, which have little suction cups on the end of them. And so basically it changes the amount of pressure in that water vascular system to create suction, so that's kind of how these organisms can move. So I did load a video so that you could see what the tube feet look like in real life, and we are going to look at some pictures too. So here, this is the underside of a sea star, and you can see all his little tube feet sticking out here. He's grabbed a clam, and once he gets all of his arms around it and suctions it, he's going to be able to open it up. And interesting with the sea stars, they have complete digestion. They have a mouth and an anus, but when they get ready to digest, because they have a very small mouth, they actually evert their stomach out into whatever they're eating. So his stomach is going to come out into the clam shells, digest the clam body, and then go back into the organism. So you can kind of see that in this video here if you take a minute to watch that video. This one is just another one where you can see different colors, but you can see the tube feet coming out. And here's just another look at you know, the large canal that goes out into the arms and then has the tube feet coming out the bottom. So this one here, this video, shows the sea star actually being able to move using the tube feet and kind of going after a sea anemone. So I'm not going to have any questions on the development of the echinoderms, but this is just so you can see. This is the early larval stage, which you can definitely draw a line down the middle and have two sides that are the same. So the larval form does have bilateral symmetry, but when it becomes the adult form, it has radial symmetry, which, like we said, is a little bit of a step back. So examples, we've talked about sea stars, we've talked about sea urchins, we've talked about sand dollars. We haven't really talked about the sea cucumbers. So this here is a sea cucumber. It has 5-part symmetry, it has spines, it has a water vascular system, all of those things that would be characteristic of an echinoderm. Most sea cucumbers are not very colorful. This one happens to be. And you can kind of see the stuff at the end here. It's part of the digestive system. And so I don't know if you've ever gone on a coral reef. I grew up not on a coral reef, but on the coast near a coral reef, and we would go out pretty much every day when I was a kid. And of course we were kids, so we did some things that we might not do as adults. But if you step on a sea urchin, they're kind of soft-bodied. It's hard for them to defend themselves. They don't move very fast, and so basically they will throw up their internal organs, which look kind of like silly string, and that's enough usually to scare a predator away. I wanted to mention one thing about the crown of thorns sea star or starfish. I'm not sure if you've heard of this before. This is you don't have to know the name, but this is the binomial name here. The common name is crown of thorns sea star. It has more than 5 arms, but it's multiples of 5, so it either has 10 or 15 or 20 arms, and you can see how spiny it is. But this is one that lives on the coral reefs in Australia. And it has become a real problem there because basically it eats the coral polyps, and then that would kill the coral reef. And this is an example of where if you try to solve a problem without having all of the information, sometimes you can make the problem worse. So the government thought, let's try to take care of these sea stars. Let's pay fishermen to go out, pick up the sea stars, cut them all up, and just throw them back in. And so we will have gotten rid of them. Well, what they didn't realize is because they have radial symmetry, they're actually all the parts that you cut up will regenerate and grow a whole new organism. So in the case of these crown of thorns, if they chopped it up to 10 pieces and threw it back into the ocean, they basically compounded the problem. So you can't kill them by cutting them in half. They'll just grow 2 more starfish. So 2 questions for perspective. First of all, do echinoderms have blood? And I don't know if you guys have watched or looked at the PowerPoint already, but they do not actually have blood. They circulate water, but they don't have the respiratory pigments like we have in our blood. And then I kind of did talk with you about this one. How does a sea cucumber defend itself? The spines aren't very defensive. It doesn't have toxins. It's not able to suffocate a predator. But if it throws up its internal organs, that sometimes is enough to scare away a predator.